Let's look at momentum and I got wrong spelling of momentum. It should be you here. Okay, momentum and impulse. What is exactly momentum? Momentum is an object. Is a product of object's mass and its velocity. Velocity, and it is denoted by letter P. Simple. In simple English, uh, momentum is how hard you can stop an object from moving. So you should know how can you get that it's hard to stop an object from it moving. Maybe if a car is moving so fast, it's really hard to stop it. Maybe a huge rock is falling from the mountain. It's really hard to stop it. Why? Because of its mass or its velocity. Since momentum is made or it's from or yes is made up of a vector quantity velocity. Obvious also momentum itself is a vector. So whenever you're writing your answers or maybe working with momentum, don't forget to show what I normally say your DMs, of which is what your your direction and what your magnitude. That's why I call it your DMs. I should mention on the other side that we had something else. We had what? We had impulse. What is exactly impulse? Impulse is a change in momentum. So it's denoted by simple change. So a change in momentum can be like this. A change in momentum. This momentum triangle is for change. What is change in momentum? Change in momentum is equal to mass. Change in momentum should be a change in velocity because mass can change. So it's going to be velocity final minus velocity initial. That is exactly change in momentum, of which equals to impulse. In a series of all my physics videos, I also mentioned something, Newton's second law. Newton's second law said for an object to move, it is required to have a force. So a force causes an object to move. Then I can demonstrate that using one of our famous equation, F net is equal to ma, of which is F net is equal to ma. Where our m is mass most obviously and our acceleration is change in velocity per unit time. So it's change in velocity per change in time. Then since change in velocity, I said it's velocity final minus velocity initial. Let me just write that, and then it's add up to this. But then I can also distribute my m inside like this, distribute him like that. Let me show you the workout after. But from this, we can now see a relationship with our previous workout. From this, we can see that it's now same as that one. It's now same as impulse. Remember here we have what? Force net or net force, should I say. Then because we said they are the same, we can now take exactly the impulse and put it here, or the change in momentum, because this is exactly a change in momentum, which is impulse. We can just put it there. Then I'm going to show you what happened after. Then we've substituted what we had here, of which was this, which was exactly here with change in momentum, of which is impulse. So we just put our impulse here. Then we can have our new equation now that tells that our impulse change in P is now equals to force net per time, or, no, or maybe times time. I think you can follow up how we derive to this formula. And this is Newton's law, Newton's second law that we are using in here. So lately I did try to explain what is exactly momentum. I said momentum is how hard to stop an object. Now I'm trying to make an example, a clear example of impulse. It's impulse is how hard you will feel pain, where this one is how hard to stop, here is how hard to feel pain. For you to feel Okay, let me write my formula here, which is just there, is equal to force times change in time. For you to not feel more pain, you need what? You need to have more contact time with something that is hitting you. A practical example of what I'm talking about. Remember, if you are falling from your house, let me say this is your house that you're falling from. This is your house, and there is a ground there. There is a ground. You will feel less pain. You will feel more pain if you're falling from your house to the ground. You feel more pain because it's the force that you come with here is just going to hit down there, and it means more pain. Because why there is why there is more pain if you fall to the ground? Because the contact time that you spend, or the contact time that you attach to the ground, is high. Well, let me say you are falling here from, yes, exactly, from your house, but now there is maybe some balloon or maybe something like a jumping castle. So if you are going to bounce. If you bounce, what is happening? The contact time that you have increase, the time increase, and the impulse what decrease. Meaning what they are inversely proportional. I can represent that. Yes, they're inversely proportional. So how much you feel is directly proportional to a force that is exerted. So if I hit you with a slap, if I exert more force, you are going to feel more pain, exactly, more impulse. But then if I try to hit you, but with the very same large force, but you tend to move away while the slap is coming, you're going to have more contact with the slap. We have more contact time. That contact time increase the pain that you feel. So I hope that makes sense. So lately I defined my impulse as a change in momentum, exactly as I've been trying to describe. Impulse is the product of the net force and the contact time. Simple as that. From this formula that we just derived from Newton's second law.